So with rounding decimals, the first step is understanding the place value system. So from primary school, all students should know that this is the units or the ones column. And then anything after the decimal point, we've got the tenths. So the tenths, the hundredths, and then the thousandths. And then of course it goes to tens of thousandths. But when they're doing rounding, the first step is always rounding to a whole number. So for example, our first example is rounding to the nearest whole number, and I've drawn a number line here because it's the easiest way to show students who are learning how to round. By putting them on a number line, they can see which end it's closest to, because rounding is going to the nearest number. So we're looking for the nearest whole number here, and I've got two examples. The first one is round 9.2 to the nearest whole. So the first step is actually finding where is 9.2 on this number line. So you can see it goes up by 0.1 each time, so it's 9.1, 9.2, 9.3. So 9.2 would be here on the green spot. So then if we have a look at this, is 9.2 closer to 9 or is it closer to 10? And students should be able to say, well, it is closer, and they can see that it is closer to 9. So 9.2 to the nearest whole would be 9. And notice how I didn't put a point or anything. It's because we're going to a whole number. So it needs to be just a whole number with no decimal point. Part B says round 9.7 to the nearest whole. So I've got 9.7 underlined in red. So 9.2 was here, which means this part's 9.5 in the middle. So 9.6, 9.7 would be where that red cross is. And you can see here, is this one closer to 9 or is it closer to 10? And they should be able to see that it is closer to 10. Now, a lot of questions come about when we say, well, what about 9.5? It is in the middle of 9 and 10. However, our rounding rules say 5 and above we go up, which means 9.5, if we were to round 9.5 to the nearest whole number, it would go up to 10, because if it's 0.5 or if it's 5 and above, we go up. If it's 4 or below, we go down. So our second example is rounding to the nearest tenth. So that is going to one decimal place. So it means that when we get our final answer, we only want one number after the decimal point. So it says here, round 3.88 to one decimal place. So firstly, we need to figure out where 3.88 is on this number line. So 3.81, 3.82, 3.83, the middle part here is going to be 3.85, which means 3.88 must be here. Now, we then say, is it closer to 3.8 or 3.9? And you should be able to see that it is closer to 3.9. And see how I've only put one number after the decimal point? That's because we're asked to round to one decimal place. The next one, round 3.83 to the nearest tenth. So 3.83 would be here on the number line with that red cross. And we're going to the nearest tenth, which still means just one number after the decimal point. So we're looking here, and is it closer to 3.8 or 3.9? It is closer to 3.8. So our answer for that one would be 3.8. So our next example is to the nearest hundredth. So when it's going to the nearest hundredth, it's going to two decimal places, because the hundredths is the second number after the decimal point. So it means our answer is going to have two numbers after the decimal point. And again, we need to work out whereabouts along this number line 8.134 is. So you can see 8.13 is at one end, so then it would be 8.131, then 8.132, 8.133, so then it would be 8.134 is there. And now we can say, is it closer to 8.13 or 8.14? It is closer to 8.13. So our answer would be 8.13, and you can see I have two numbers after the decimal point because I have been asked to round to two decimal places. The next one, 8.139. Whereabouts does that sit on the number line? It would be up here, just before 8.14. and where the red cross is, and you can see that it's very close to 8.14. So our answer for that one would be 8.14 to 2 decimal places. So with example 3, going to 3 decimal places or the nearest thousandth, you can see in the previous example, the determining factor was that final number. So if we're asked to go to 2 decimal places, we were looking at this number, the number 4 there, that is what determines whether or not we go to 8.13 or 8.14. So here it was the 9. And if we go back, when it was going to 1 decimal place, it was the second number after the decimal point that told us whereabouts it was on the number line, in which case, where was it closer to? So when we're rounding to 3 decimal places, we're actually looking for the 4th number. So the 4th number after the decimal point in this first example is 4. And if we look at it, is it going to make it go past that halfway point to the next number up, or is it going to go back down to the number that was before it? Now, because it's a 4, it's not past halfway. So it means that this number would just stay as 5.183 to 3 decimal places. However, if you look at the next one, we're looking at the 6. Now, the 6 pushes it past that halfway mark of a 5, which means it forces this 3 to go up to a 4. So we end up with 10.294, because that upper and lower boundary, if we were to put it on a number line, would be 10.293 and 10.294, and that 6 would mean that we're closer to the 10.294. So then for the third example here, we're looking at a 5. Now again, a 5 is halfway, but if it's 5 or more, it goes up. So it means that it is technically, we say it's closer to 12.836 as opposed to 12.835. The last one's a little bit tricky because I have a bit of a problem here in the way that it's a 7. Now the 7 means it's going to go up, but we can't go up with a 9, can we? We've got to think about what would those boundaries be on a number line. So you'd have one boundary as 7.849. The next boundary would be 7.850. And then we've got all those little numbers in between, which means that 7, yes, it does push that 9 up because it makes it go to 7.850. Notice how I still wrote 3 numbers after the decimal point, because we are rounding to the nearest thousandth, which means there has to be 3 numbers after the decimal point, even though 7.85 and 7.850 are the exact same number. So the main points to consider here is, if you're asked to round to 3 decimal places, you're looking at the 4th number after the decimal place. So you're always looking at the next number after what you have been asked to round to. And then once you've looked at it and you've found that, you then decide if it is a 0, 1, 2, 3 or a 4, then the previous number is not going to change. If it is a 5, 6, 7, 8 or a 9, it pushes that number before it up, and then you need to change it because it is closer to that upper boundary on the number line as opposed to that lower boundary. Hopefully this helps you with your rounding.